Every generation of students is taught the same sentence. Light is both a wave and a particle. It is presented as wisdom, repeated as resolution, and accepted as explanation. In reality, it ends understanding. Once spoken, the sentence shuts down inquiry. It sounds paradoxical, deep, and final, yet it explains nothing. It survives not because it reveals nature, but because it hides our failure to abandon classical thinking. Light is not sometimes a wave and sometimes a particle. It is not both at once. It does not switch identities depending on how we look at it. This claim is not radical. It is the sober conclusion reached by physicists who took quantum theory seriously, including Richard Feynman, who repeatedly warned that the real mystery lies not in light itself, but in our insistence on asking the wrong questions. Classical physics divided the world cleanly. Waves were extended disturbances, spread through space, capable of interference and superposition. Particles were localized objects, discrete, countable, following trajectories. These were not just models, but assumptions about what could exist. Sound was a wave, stones were particles, and motion meant following a path. When light entered physics, it was forced into this framework. The 17th century argued over it, but the 19th century appeared to settle the matter. Interference and diffraction destroyed the particle picture. Maxwell's equations crowned light as an electromagnetic wave. By 1900, light was no longer debated. It was a wave. Then experiments broke the verdict. The photoelectric effect showed that light transfers energy in discrete amounts. Increasing intensity did nothing unless the frequency crossed the threshold. Energy arrived in lumps instantly. A wave could not do this. The conclusion was not philosophical, but compulsory. Light interacts discretely. Physics faced a contradiction. Interference demanded waves. Energy exchange demanded particles. Instead of abandoning the categories, physics kept both. The compromise was called wave-particle duality. It was never a theory. It was a ceasefire, a way to speak while admitting confusion. Over time, the placeholder hardened into dogma. Textbooks declared that light behaves like a wave while traveling and like a particle while interacting. This sounds sensible until examined. Traveling through what? Interacting as what? No experiment ever shows light transforming from wave into particle. What changes is not light, but the experimental arrangement and the quantities measured. The duality story smuggles in the false assumption that light possesses classical properties that reveal themselves selectively. It does not. The double-slit experiment exposes the failure clearly. Light produces discrete detection events. Over time, those events form an interference pattern. The popular story claims that each photon is both wave and particle, that a wave goes through both slits while the particle lands at one point. This story describes no mechanism. It only stacks metaphors. The experiment itself says less and more at the same time. Individual events are localized. Their statistical distribution follows wave-like rules. Nothing in the data requires light to be a wave or a particle. Those are imported images, not observed facts. The deepest error is the belief that measurement reveals what light already is. In quantum mechanics, measurement does not uncover pre-existing properties. It defines the conditions under which outcomes occur. Position measurements yield positions. Momentum measurements yield momenta. These are not masks pulled from the same object. They are mutually exclusive experimental contexts. Light does not carry a hidden identity. There is no internal switch. There is only preparation, interaction, and probabilistic outcome. Wave-particle duality survives because it is pedagogically convenient. It preserves intuition, avoids mathematics, and offers comfort instead of clarity. It reassures us that reality is strange but still familiar. It allows us to believe that classical pictures still apply if handled carefully. They do not. The failure is not in light. The failure is in our insistence that reality must consist of picturable objects. Quantum theory does not describe things moving through space and time the way classical physics does. It describes rules for predicting correlations between events. Light is not a substance changing costumes. It is not half wave and half particle. It is governed by a mathematical structure that does not reduce to classical imagery. Most explanations avoid this admission because it removes the safety net. Yet without accepting it, confusion is guaranteed. This is where the discussion must turn. Away from waves, away from particles, away from pictures, toward a framework that abandons intuition instead of patching it, toward probability amplitudes, paths, and the uncomfortable conclusion that nature does not operate in terms of objects at all, only in terms of interactions and rules. That turn is where Feynman begins. What Feynman was really saying. Quantum mechanics fails the moment we ask the wrong question. What is light sounds natural, but it assumes that light must be a thing with intrinsic properties waiting to be uncovered. That assumption belongs to classical physics, where objects exist first and equations describe them later. Quantum theory reverses this order. The equations come first, the predictions work, and the object never appears. This reversal is not philosophical rebellion, it is enforced by experiment. No physicist accepted this more honestly than Richard Feynman, who refused to decorate mathematical rules with comforting stories. The double-slit experiment is often treated as a riddle. Feynman treated it as a boundary marker beyond which classical reasoning simply stops working. Light is emitted, discrete detection events occur, and the distribution of many events forms an interference pattern. Any attempt to determine which slit was involved destroys that pattern. These facts require no interpretation, no mysticism, and no metaphor. Everything beyond them is narrative invention. Feynman's discipline was strict, never described what cannot be calculated. Quantum mechanics does not predict individual events. It predicts probability amplitudes. These amplitudes are not probabilities, but complex quantities that must be added before squaring. Classical probabilities add because alternatives exclude one another. Quantum amplitudes interfere because alternatives coexist mathematically. When light travels from source to detector, the theory assigns an amplitude to every possible path. Straight paths, curved paths, absurd paths that loop and wander, all are included. Most cancel out, a few reinforce. The result predicts the observed distribution. This is not a picture of motion, it is a computational rule. This destroys the idea of trajectory. In classical physics, a particle follows a path, whether observed or not. In wave physics, a disturbance propagates continuously. Before Kerr explained that past non-sequestral pearl. A juurtehakte scrib, then skeptimal minkelium balkol dosiana arabuosa. It destroys the idea of trajectory. In classical physics, a particle follows a path, whether observed or not. In wave physics, a disturbance propagates continuously. In Feynman's formulation, there is no underlying motion at all. There is only a sum over possibilities. Measurement is often described as disturbing light. This language is misleading. Measurement does not reveal a hidden property that was already there. It creates the conditions under which an outcome can exist. An apparatus that measures position defines position as an outcome. An apparatus that measures momentum defines momentum as an outcome. These arrangements are mutually exclusive. There is no complete set of properties waiting to be sampled. Experimental context is not a nuisance, it is fundamental. At this point, both classical categories collapse. The particle picture fails because particles have trajectories in well-defined locations prior to measurement, which light does not. The wave picture fails because waves are physical disturbances in a medium continuous energy distribution, which light is not. Wave-particle duality survives only by blending two failures into one sentence and hoping the contradiction passes unnoticed. It does not. Feynman refused to replace one metaphor with another. He did not say light is a strange wave or a fuzzy particle or information or consciousness-dependent reality. He said, in effect, this is how nature computes outcomes. And the theory makes no claim beyond that. The scandal of quantum mechanics is not that it is mysterious, but that it works perfectly without providing a story of what exists between measurements. Physicists accept this pragmatically. Students are rarely allowed to. The idea of wave function collapse illustrates the confusion. Collapse is not a physical process occurring in space and time. It is a change in mathematical description once an outcome is registered. Nothing jumps, snaps, or chooses. Treating collapse as a physical event is mistaking a bookkeeping update for a mechanism. Feynman avoided collapse language entirely, not because it was forbidden, but because it explained nothing. The discomfort with this framework is psychological, not scientific. Humans want objects, narratives, and causal sequences unfolding in time. Quantum mechanics offers correlations, rules, and predictions without stories. Wave-particle duality comforts us by pretending the old pictures still apply. Feynman removed that comfort. He did not say, here is a better picture. He said, stop demanding pictures. In this view, light is not something traveling through space. It is a rule governing interactions between sources and detectors. Preparation, interaction, outcome. That is all the theory describes. Between those points, there is no event, no behavior, and no hidden process. This is why Feynman said no one truly understands quantum mechanics, not as an admission of ignorance, but as a recognition that classical understanding itself has reached its limit. Once this is accepted, wave-particle duality does not merely become undesirable. It becomes actively misleading. Light does not have two natures. It has no classical nature at all. Duality is not deep truth, but historical scaffolding that should have been removed once the building stood. The cost of misunderstanding. Wave-particle duality is often defended as a harmless simplification, a temporary story for beginners. This defense collapses under examination. The problem is not that the idea is incomplete, but that it is wrong in the specific way that misdirects understanding. Students do not merely lack detail, they acquire a false conceptual structure. Once that structure is in place, later learning becomes an act of unlearning. Confusion is not an accident of quantum mechanics. It is manufactured by the metaphors used to teach it. Historically, wave-particle duality was never meant to be permanent. It emerged during a transitional period when classical physics had failed, but a replacement framework was still forming. It was a linguistic ceasefire, not a theory. Once quantum mechanics stabilized mathematically, the placeholder should have been discarded. Instead, it was preserved, repeated, and canonized. What began as an admission of confusion hardened into a declaration of truth. Temporary language became permanent doctrine. Many physicists are aware of this. They repeat the duality anyway. The reason is not dishonesty, but exhaustion. Teaching quantum mechanics honestly requires saying things that sound unacceptable. There is no underlying classical picture. The theory does not describe reality between measurements, and many familiar questions have no meaning within the framework. These statements are difficult to test, difficult to grade, and emotionally unsatisfying. So metaphors are reintroduced, not because they are accurate, but because they are manageable. Error propagates through convenience. Once wave-particle duality is removed, nothing replaces it at the level of imagery. This is the point most explanations avoid. There is no correct picture waiting behind the wrong one. Quantum mechanics replaces classical description with formal structure, state vectors, operators, amplitudes, and rules for updating predictions. These are not representations of hidden objects, they are the theory itself. To demand a picture beyond them is to demand something the theory never promised. Light within this framework is not an object moving through space. It is not a thing at all in the classical sense. It is an excitation of a quantum field whose entire physical content is exhausted by how it participates in interactions. Emission prepares a state. Detection registers an outcome. The theory connects these statistically. Between them, there is no described process unfolding in time. This absence is not a gap in knowledge, it is the structure of the description. The slogan, often summarized as "shut up and calculate," is widely misunderstood. It is not anti-thinking, it is anti-conflicting. Richard Feynman did not reject understanding, he rejected stories that felt like understanding while explaining nothing. A theory can be complete without being picturable. Insisting on pictures is not depth. It is nostalgia for a world that no longer exists.
The cost of preserving the duality myth is measurable. Students learn to treat contradiction as profundity instead of warning. Quantum mechanics becomes mystical rather than precise. Mathematical structure is resisted in favor of imagery that actively misleads. Poor metaphors invite metaphysical excess. Consciousness caused collapse. Observer created reality. And other claims that sound deep precisely because they are untestable. These are not harmless misunderstandings. They distort how reality itself is discussed.
An honest teaching would state the facts plainly. Experiments produce discrete detection events. The statistical distribution of these events is predicted by probability amplitudes. The theory does not describe what happens between events. Classical categories do not apply. This sounds harsh only because we are accustomed to gentle lies. Clarity feels cruel only to those trained on comfort. The final conclusion is therefore not paradoxical but sober. Light is not both a wave and a particle. That sentence is not profound, it is evasive. Light is described by a theory that does not reduce to classical pictures, and pretending otherwise guarantees confusion. The true mystery of quantum mechanics is not hidden behavior, but the absence of behavior in the classical sense. Once this is accepted, the mystery does not deepen, it dissolves.